Hello, students, and welcome back to class. Today we're going to graph some exponential functions. Before we do, let me congratulate you all on how well you're doing. You're turning in a ton of work. It's quality work. You're doing a great job of showing your work along with your answers. You're doing great. If we're going to graph some exponential functions, there's a few facts we should brush up on first. Let's look at these exponent problems. If you can do them all in your head, it sure makes graphing exponential functions easier. Let's try them. 6 squared means 6 times 6, 36. Anything to the first power is just itself. When we take things to the 0 power, anything to the 0 power is automatically 1. 4 to the negative 1, a negative 1 exponent means reciprocal. 4 to the negative 1 is 1/4. If I take 8 to the negative 2 power, it means square it and take the reciprocal. 8 squared is 64. The reciprocal would be 1/64. When I take 1/4 and square it, 1 times 1 in the top, 4 times 4 in the bottom. Here's something to the 0 power again. Anything to the 0 power is 1. Remember that a negative exponent means reciprocal. The reciprocal of 1/5 is 5/1. And if I take 1/6 to the negative 2 power, it means take the reciprocal and square it. If I take the reciprocal, it's 6. 6 squared, 36. Now it's time to graph a couple of exponential functions. I'm going to remember that f of x is just the formal name for y. I can rewrite f of x equals 3 to the x as y equals 3 to the x. When I graph basic exponential functions, I like to let my x values be -2, -1, 0, 1, and 2. Let's plug those x values in and see what y values we get back. I'm going to start with the last one. Start by letting x be 2. If I plug 2 in for x, 3 to the second power, that's 9. Now plug in 1 for x. When I plug a 1 in here, anything to the first power is itself. When I plug in 0, anything to the 0 power is 1. -1 as an exponent means reciprocal. And -2 as an exponent means reciprocal and square. Let's see if we can plot these. We're letting x be 1, 2, -1, -2. When x is 1, y is 3. When x is 1, y is 3. When x is 2, y is way up here at 9. When x is 0, y is 1. Now when x is -1, we start getting closer to 0. And when x is -2, we're even closer to 0. The x-axis serves as an asymptote, and then our exponential function increases and increases and increases ever more rapidly. Now, we'll never touch the x-axis. The x-axis is an asymptote, which is a straight line that the curve will never touch. It'll just keep getting closer and closer and closer and closer. Don't let your curve start to curve back up again. That's not what it does. It keeps getting closer and closer to that x-axis. For full credit, let's label the y-intercept and then label one more point. Let's try that again. New exponential function. I'll rewrite f of x using its common name of y. And I'm going to let my x values be -2, -1, 0, 1, and 2. Let's start by plugging in the -2. If I plug in -2 here, -2 means reciprocal and square it. The reciprocal would be 5, and 5 squared would be 25. Let's plug in -1 for x. When I plug in -1 here, -1 as an exponent means reciprocal. The reciprocal of 1/5 is 5. Plug in 0. We know anything to the 0 power is 1. When x is 1, anything to the first power is itself. And when I plug in 2, that means square it. 1 squared is 1, while 5 squared is 25. Let's get a nice graph. x1, x2, x0, x -1, x -2. When x is 0, y is 1. When x is -1, y has gone all the way up to 5. When x is -2, y has gotten very large. Would be way up here somewhere. When x is 1, y starts to get close to 0. When x is 2, y is even closer to 0. Do you see that the x-axis, again, serves as an asymptote? The x-axis is an asymptote. There's what my function should look like. Never touching the x-axis, never curving back away from the x-axis. It's a decreasing function that decreases very quickly and then decreases slower and slower and slower and slower as it approaches the asymptote. Let's label the y-intercept and label one more point. All right, there's the way I want your work to look like. Give me the XY chart, give me the graph, label 2 points on each graph. All right, your turn. Meet me back here when you're done practicing.